You may have heard people talk about LODs or rave about LODs. You may have looked at LODs before, but not quite sure how to use it or when to use it. We will demystify LODs in this video. I will take you to the world of LODs, or level of detail expressions, which are very powerful calculations in Tableau. LODs simplify a lot of the complex calculations we need to do. For this particular video, we will use the Superstore dataset because it will make it easier to demonstrate some of the concepts, and it will be easier for you to follow along when you have access to the same dataset. In future videos, we will use different datasets to look at additional use cases for LODs. I'll see you in a bit. If you need a calculations refresher, please check out part 1 of this calculations series. I will put up a link in the card above. In this video, we'll talk about LOD expressions, what they are, types of LOD expressions, the syntax, and we'll go through examples for each type of LOD. When trying to understand LOD expressions or level of detail expressions, the first stop should be the online documentation. This is the definition offered in the Tableau online documentation. So it says here, level of detail expressions, also known as LOD expressions, allow you to compute values at the data source level and at the visualization level. However, LOD expressions give you even more control on the level of granularity you want to compute. So the key word in here is even more control on the level of granularity. They can be performed at a more granular level, a less granular level, or an entirely independent level. So if we were to summarize the definition, LOD expressions allow you to control the granularity or the level of detail of your expression. And the two key things here are granularity and the level of detail. Sometimes though, the biggest barrier that I find in even just understanding what LODs are all about, it starts with these two keywords. What does granularity mean? What does level of detail even mean? I like looking up definitions because they help me understand the concepts when I read them. So I open up my trusty browser, go to Google, and look for the definition of granularity. So according to Wikipedia, granularity, also called graininess, is the condition of existing in granules or grains, refers to the extent to which a material or system is composed of distinguishable pieces. And for me, the most helpful phrase here is distinguishable pieces. It lets me know that when we talk about granularity, we're talking about individual, distinguishable pieces. So for me, granularity and level of detail, it really translates to this question. What does each mean? And when we talk about each, it's actually each number. What does a number represent? Or it's a mark. Maybe it's a bar, it's a line, it's a dot. What does each mark represent? What do they mean? This is another definition I found for level of detail, and it makes me realize that actually we use this term in our conversations. We could be talking to coworkers, and sometimes we just want them to give us a high-level overview, or in some cases, we don't want just a high-level summary, we want all the details. So when we talk about high-level, we're really talking about summary. We want to leave out any additional details, which means it's less granular or it's more aggregated. When we talk about low level, we mean include all the details. We want more details. It's more granular, therefore less aggregated. So how does this tie back to Tableau? Tableau works natively like this. The level of detail in Tableau is what's being shown on your view. Every number that you see or every mark that you see is actually the level of detail in Tableau by default. We're going to jump to Tableau shortly to demonstrate this, but think about it. When you drag over a measure, for example, sales, by default it gets aggregated in your view, it's sum of sales. But what does sum of sales really mean? Well, the answer is it depends. It depends on what else is in your view. Sum of sales could be a grand total sales, and sum of sales could be a subtotal by category, a subtotal by subcategory. Let's take a look at this in action. Let's have a quick look at the data source first. This is the sample Superstore dataset. The level of detail of one line in this data source represents a transaction line. So one line represents a transaction at an order date level, at a specific ship date, at a ship mode for a specific customer, for a specific segment, a country, a region, etc. That is the level of detail. That is what one line in this Excel sheet represents. We are in Tableau right now to take a look at what level of detail means in Tableau by default. I've already connected to the sample Superstore dataset. Let's drag over a measure. Let's take sales and put that on text. So this measure, sum of sales, what does this mean right now? Well, right now, because we don't have any other dimension in our view, this tells us the grand total. It's the sum of all of the sales of all of our records in our data set. So the level of detail of this one number is at the data set level. It's the one number that represents all of the records in our data set. So notice in here, we're not going to change this measure, but if we simply add one more dimension, what happens to that original number? Well, the original number disappears. But note in here that this sum of sales, this means different now. This sum of sales is actually now the sum of sales at the level of category. Each number that you see in here is at the level of category. It's at the detail of category. 742,000 is a number that represents furniture, which is a value in category. The more we add dimensions, the more granular the number becomes. So for example, if we drag over subcategory, again, those numbers change. The sum of sales, the actual pill, we haven't changed it, but the number that gets displayed has a different meaning now. Right now, sum of sales is at the level of subcategory and category. This is now a subtotal. It's a more granular subtotal. So now that we understand how level of detail works in Tableau natively, let's take a look at the types of level of detail expressions. These are the three types of level of detail expressions. We have fixed, exclude, and include. I'm going to give you a quick round of definitions right now, but we're going to expand on this later on in this video. A fixed LOD expression means the number that you're calculating is independent of what's in your view. It's independent of what's being shown in Tableau. Exclude, think of it as subtracting dimensions from your view. It's as if those dimensions are not in your view. And include, think of it as adding dimensions in your view, even if those dimensions are really not there. But that's how your calculation sees it. Let's talk about syntax. The syntax will be the same regardless of the type of level of detail expression you're using. The key components of an LOD expression, first and foremost, is that it's encapsulated in curly braces. Those are your curly braces right there. Curly brace. After this, you're going to specify the type. And in here, you have a dimension list. And notice that you have square brackets around it. Square brackets mean they're optional. So you could potentially have an LOD expression that has one dimension, multiple dimensions separated by a comma, or maybe even none. After your optional dimension list, you need to have a colon, and the final component just before your ending curly brace is an aggregate. When we say aggregate, this is typically your sum, your minimum, your maximum, etc. When you're first starting out with your level of detail expressions, my recommendation is for you to build a text table first that has the numbers that you want, and use this text table to compose your LOD expression. This approach really gives you two things. First, it gives you a reference. It's almost like a cheat sheet. This tells you all the dimensions you need in your expression to get the number that you want. In this text table, you simply need to reference all of the blue pills, all of those discrete dimensions that you already have there that help you generate that number. Having a text table also gives you a validation point. You can check against these numbers to ensure that what you get from your expression is correct. And sometimes that's the challenge with Tableau. We're not always just creating text tables. Sometimes the numbers that we have are in a chart, and sometimes that makes it harder to double check and validate the numbers. So having this side by side allows you to double check that number, and it also allows you to compose that level of detail expression more easily. So for our demo, something similar to this is what we want to accomplish. If you simply look at the sales map, we can tell that the level of detail at the visualization level, the level of detail that is being shown by this map, is actually at the state level. So we can see all the borders to the state. However, when we hover over this map, we can see that there are numbers that are being displayed that are different from the level of detail of the visualization. In addition to the state level, we also roll up to a region level. So there's your region. We also further roll up, so all of these regions, we roll up to the country level. The level of detail of the visualization is at the state level, but we can also choose to show something that's more granular than what we're showing in our visualization. In here, we're also displaying numbers at the customer level, even though we're not showing each individual customer in the viz. So now let's walk through the different LOD types and see how we can achieve all of these different levels of detail in a single viz. I hope you're finding this video useful so far, and if you haven't subscribed yet, please consider subscribing. I publish weekly videos on data-related topics like Tableau, SQL, databases, and data warehouses. The first type of LOD expression is the fixed level of detail expression. And this is probably the most common that you're going to see in examples or resources that you encounter. The fixed level of detail expression only looks at the expression for the granularity. It doesn't care what other dimensions are in the view. For the number that it needs to return, it only looks at the expression. The fixed LOD expression also returns a scalar, meaning it returns a singular value. Let's demonstrate fixed level of detail expressions. Let's take sum of sales and drag it to text. Let's say we care about this number and we want to keep this number regardless of which other dimensions are displayed in our view. If we were to create a fixed level of detail expression, again, my recommendation is to create a text table first, and this is an example of a text table. And in here, we can see that there's no other dimensions in our view. So if we were to compose this fixed level of detail expression, our expression would look like this: curly brace, fixed. Remember, the type of LOD is followed by a dimension list. And in this case, there's no other discrete dimension in our rows and our columns and our details. So in this case, we can skip this because remember, dimension list is optional. We put our colon, and our aggregate is actually the sum of sales. We simply just need to put that in our expression. Don't forget to close the curly brace. So let's create this calculated field. Create calculated field. I'll just call this fixed grand total. Fixed grand total, keyword fixed. Again, no dimension list, colon, and in here we can simply drag over our aggregate. So if we click on apply, and if we display this calculated field, we can see that we have the 2.297 million. Let me just move measure names to columns. And notice in here what happens to these two numbers once we introduce a discrete dimension. For example, when we drag over category, the second column, which is sum of sales, this is our sum of sales right here. This is how Tableau works natively. The level of detail in the measures is determined by the discrete dimensions you have in your view. Therefore, this sum of sales is actually sum of sales grouped by category. However, our fixed grand total, this is a fixed level of detail expression. It basically says, I don't care about what else is in the view. All I'm going to look at is this expression. And in this expression, there's no dimensions. So this simply just calculates sum of sales as if there is no dimensions in the view. Let's add some totals here. So under Analytics tab, double-click on Totals. Let me just also add a filter for category. So on the drop-down, Show Filter. One thing to note about fixed level of detail expressions, they are not going to be affected by dimension filters. So we added this dimension filter for category. Even if we deselect some of these values, this number will not change. It's not going to be affected by dimension filters. So just notice what's going to happen in this grand total. Let's uncheck furniture. Let's uncheck office supplies. Notice that our fixed level of detail expression is still 2.297 million. However, the sum of sales, which represents Tableau's default behavior, this has changed. It was affected by dimension filters. So again, fixed level of detail expressions, these expressions are evaluated independent of the dimensions you have in your view. And this is what our example looked like. There's also another special variation of fixed level of detail expressions. If you do not supply the type of LOD and the dimensions, so simply all you have are the curly braces and the aggregate, for example, sum of sales, again, no type, no dimension list, this is treated as a fixed level of detail expression, and it's some kind of a grand total. And we call this fixed table scoped LOD. We have also mentioned that fixed level of detail expressions, they're not affected by dimension filters. So this is the perfect time to introduce Tableau's order of operations. You can find this diagram from Tableau's online help or online documentation, but this outlines the order of operations or the hierarchy of operations. What this tells us at the very top is if we add extract filters, basically all operations in Tableau respect that extract filter. It's not going to operate on any data that it doesn't see from the extract. In terms of level of detail expressions, fixed level of detail expression is actually right here. And what this tells us is fixed level of detail expression sits around this side. It's above the dimension filter, but below context filters, also below the data source and the extract filters. So this means the fixed level of detail expressions, they see and respect context filters, data source filters, and extract filters. But fixed level of detail expressions, it's above the dimension filter, so it doesn't see that operation at all. And this explains why when we added our dimension filter on category, the 2.297 million did not change. It's also important to note in here that the other two types of level of detail expressions, include and exclude, these two sit below the dimension filters. So this tells us that include and exclude are going to be affected by the dimension filters. So this is one big difference between fixed LOD and the include and the exclude LODs. So let's just quickly jump back to Tableau again. Remember our fixed level of detail expressions, it's not going to be affected by dimension filters, and we can see in here that the value does not change. But we also know now that fixed level of detail expressions will recognize context filters. So if we change our category filter and make this a context filter, so when you click on this drop down and add this to context, notice what happens when we uncheck values from our filter. We can see now that the actual value for the fixed level of detail expression has changed because it recognizes our context filter. Let's now take a look at the exclude LOD. The exclude LOD respects and recognizes all of the dimensions that are in the view, but removes the dimensions that are found in the expression in its calculation. The result of an exclude LOD is not a scalar value. It will return its result as an ATTR, and this is an aggregated value. The ATTR, or the adder function, is an aggregation function. We'll cover this in a future video. The other thing to note is that exclude LODs are affected by dimension filters. Remember the order of operations. Let's jump to Tableau and take a look at how exclude LODs work. So for example, you have this text table. What if you need to have a grand total? What if you needed to have this 2.297 million as columns? Now you have a couple options. Your first option is to define a grand total based on a fixed LOD. So in that fixed LOD, you're simply not going to pass in any dimensions. That expression is independent of the view and is also not going to be affected by dimension filters. But what if you want this field to be affected by dimension filters and you don't want to add context filters everywhere? Your other option is an exclude LOD. So in this case, the number we really want is the 2.297 million. Visually, we can get to that 2.297 million if only we remove category. But if your view really needed category, your other option is to use the exclude LOD. So what will your expression look like? Remember, you're going to have your curly brace. This time, this is going to be an exclude LOD. So let's put in exclude. What are we excluding? Well, we don't want category, so we're going to exclude category here. Colon, and then the aggregation that you want is just this same measure. So let's put this in an actual calculated field. Create a calculated field. Let's call this exclude category. And from here, our curly brace, exclude. We want to exclude category, colon, our aggregate, closing curly brace. Let's double click on this new number and we can see in here the 2.297 million. But notice what happens when we add a category filter. So on the drop down, show filter, and if we exclude one of the values, we can see that that number gets updated because remember, exclude LODs are going to be affected by dimension filters. What if you needed to add subcategory here? So let's drag subcategory over. Now all of a sudden, your exclude category numbers is no longer your grand total. We can simply amend our calculated field. So right click on exclude category, edit this, and in your dimension list, we can simply just add subcategory if you want to exclude that from the calculation as well. So just put a comma in and drag subcategory. Once we click on apply, we should see our original grand total number that is affected by our dimension filters. The third LOD type is the include LOD. So this is very similar to the exclude LOD. The result is an aggregate in the form of the adder. The result of an include LOD is also affected by dimension filters. And really the only difference between include and exclude, the exclude LOD subtracts or takes away a dimension in its own expression. Therefore, it gives you a rolled up value. It gives you a more aggregated value. The include LOD includes more dimensions, so it puts more detail in. Therefore, it's more granular, so it's less aggregated. Let's jump to Tableau and demonstrate what include LODs are. We are back in Tableau to demonstrate include LODs. What if in addition to sales, you needed to display the average regional profit for each of these categories? But the other requirement is to also not show region. Remember that one of my recommendations is to create a text table first and get the numbers that you want and use that as a reference or as a cheat sheet. So let's create a table that has what we want. Let's create a brand new sheet. Let's call this our include cheat sheet. And what we want is our category. We want the profit. And we also want the region. So let's drag region over. Let's add our totals. So in this case, analytics. Let's double click on totals. By default, these totals are based on sum. So it basically adds all of these numbers. But what we want is the average of these four numbers. So in Tableau, we can change the aggregation of our totals by clicking on the measure. And from here, instead of total using automatic, we can choose a different aggregation, and in this case, an average. So right now, this is our cheat sheet. If we are successful in creating this calculated field that has our include LOD, the value for furniture has to be 4,613. This is our checkpoint. In our original visual, we only have category, but our number, our calculated field, also needs to include or consider region. So our expression will look like this: curly brace, include. We want to include region. We put our colon in. Now this is where it's going to be a little bit tricky. Our aggregation is still sum of profit. But remember, our requirement is about the average. But take a look at this table. Each one of these values is the sum of profit. It's only the total that has been averaged. So we have to sum it up first and then get the average of the sums. So in this case, we're going to embed this expression inside another aggregate function. We have to pass all the values that we get in here into an average function. Again, let's just have a closer look. Each one of these values, that's the sum of profit. We take all the sums and we pass it to an average function. So it's technically an aggregate inside an aggregate. So let's create this calculated field. On the drop-down, create calculated field. Let's call this average regional profit. Again, the main level of detail expression that we have is a curly brace, include. We're going to include region. And in here, we're still looking at sum of profit. Actually, let's just drag that over. Sum of profit. Now what's going to be different in here is within this same calculated field, we can just pass this whole expression inside an average function. So we can do it this way, or we can do it at the visualization level. I'm just going to choose to do it within the expression. So in here, put average and click on OK. So let's test it out. Let's see if it works. So our target value is furniture is $4,613. Let's go back to our previous sheet, average regional profit. And here we go. So now let's try to put it all together. Let's now try to recreate this view where you have a map at the state level, yet your tooltip shows a country level value, a region level value, a state value, and then a customer level value. So let's start by building our map. Double click on state, and in here we're going to take region to color. We're going to put state to label. We're going to change this to a filled map. We can put sales on tooltip. By default, this number is at the state level because our visualization is at the state level. So now to add a country level sales, we have a couple options. You can either create a fixed grand total, or you can use an exclude LOD, removing region and state. What could influence your decision is if you want this number to be affected by dimension filters. So for this example, I'm just going to use a fixed LOD. So let's create a calculated field, and here let's just call this fixed country sales. And in here we can use a fixed table scope LOD, which means all we need is a curly brace and your aggregate. Let's add this to our tooltip. For the regional sales, it's the same thing. You can choose to have a fixed level of detail expression that only looks at region, or you can also use an exclude LOD that excludes state. Just for demonstration purposes, let's use exclude this time. Create a calculated field. Let's call this regional sales. And in here we want to exclude our state. And let's add sum of sales. Let's also just create a regional sales text table so we can just double check our numbers. So let's drag region and then sales. Now for the average customer sales and state, I'm going to start this with a text table. It just makes it a little bit easier for us to compose our expression. In our original viz, we actually had region and state, so I'm just going to duplicate that inside our text table. Let's grab region, state, and this time around, I'm going to add customer ID. And let's display sales for each customer. Under the Analytics tab, let's add totals. Under Analysis, Totals, let's display all of the column totals to the top. And instead of sum, we want this to be an average. So on the drop-down of the measure, total using average. So this can be our checkpoint. For Illinois, in Central, we are looking for the value 338. That's the average of their customer sales. So let's create this calculated field. On the drop-down, create calculated field. Let's call this average customer sales in state. And in our original viz, we know that we already have region and state. So we only need to add customer ID. So in here, include customer ID. Our aggregate is sum of sales, closing curly brace. And because we're looking for average, let's add average in here. So AVG. And let's click on OK. So moment of truth, we need to find Illinois and make sure that the value is 338. So let's add average customer sales in state to tooltip, as well as our regional sales where we used our exclude LOD. So let's drag that over to tooltip as well. So now let's create a dashboard so we can easily cross-check our numbers. So from here, drag our map over. Let's add average customer sales by state. Let's add it down here. Let's leave only Illinois, keep only, and drag regional sales over. And we're just going to keep central. So let's take a look at Illinois. We know the country sales is right. This is our 2.297 million grand total. Sales is the sum of sales, which is Tableau's default behavior for level of detail. Average customer sales in state is 338, and that's correct. And the regional sales where we used the exclude LOD is 501,240. So this is your introduction to the world of LODs. I hope you found this video useful. I hope this provides you a good foundation as you explore more use cases for LODs. I also want to direct you to this resource, the Top 15 LOD Expressions by Bethany Lyons. It goes through 15 of the most common use cases for LODs, and you can also download the workbooks so that you can reverse engineer and study it at your own pace. Again, I hope you found this video useful, and I will see you again next time.